Hi everyone, this is Dr. Poe, and I just wanted to briefly talk to you today about energy in reactions, specifically differentiating these terms endothermic and exothermic. So when we're just looking at the terms exothermic, the exo typically means outside, like an exoskeleton would be outside, and thermic is related to temperature. And endothermic is going to be inside, so endo is inside. So the temperature is going inside. So that's the real difference between these terms. So in exothermic, and it's telling us where the temperature is going. In an exothermic reaction, heat is released. So it is leaving the system, it is going elsewhere. So that's why exo is like outside. So this energy is going outside. In an endothermic reaction, heat is brought in. So that's where we get this endo. The endo means inside, the heat is being brought into the system. So the easiest way I've kind of like thought about this is in terms of ice cubes. So here's my beautiful ice cube right here. And as I'm holding the ice cube on my hand, drawing hands is maybe a little bit beyond my artistic ability, it is going to melt and become water. So here's my little stick figure holding my ice cube. So that's me. Holding my ice cube. The heat from my hand is going into the ice cube, and that ice cube melts and becomes water. So we started with a solid, and now we have a liquid. And what did we do? The heat is being put into our ice cube. So this is endothermic. We are adding heat. Then, I decide that I want to boil some water. So I'm going to add a little heat source here. And, here it's going to make this gas, our steam. So again, when I'm boiling water, that's going to be liquid to gas. That is, again, going to be endothermic because we are adding heat into the system. And hopefully all of these examples are really, really intuitive for you. What might be a little bit less intuitive is the reverse. But if this way, like solid to liquid, anytime that happens, that is endothermic. We are putting heat into the solid to melt it to become a liquid, and we are putting heat into a liquid in order to give that additional energy for it to become a gas. So those are always endothermic processes. Water is a really great example because we can see that existing in all three phases. But in the reverse is going to have to be the opposite. So if liquid to gas is endothermic, gas to liquid is going to be exothermic. So what the exothermic means is that heat is going to be released. So we're going to have a little bit of energy coming out. So E being energy. So when gas condenses on the side of a window or on the side of a glass, that is actually an exothermic process, and that's going to be releasing energy. So when you put your hand in steam, what's actually happening, what causes that burn that you're going to receive, is that extra energy is going to go straight into your hand because it's an exothermic process. And similarly, if we want to take this liquid and make it a solid, we got to take some energy out of that in order for those molecules to slow down and form a solid shape. So that is also going to be exothermic. So you can understand why, maybe those exothermic processes, you got to think about it a little bit more, that heat is being released from the system, the energy is coming out of the system. But the more you think about it, the more you can observe this, the more it does make sense. So I hope that this video has been helpful to you in terms of differentiating exothermic and endothermic.